What's up, people? Long time no see. How are you guys doing? I hope all of you guys are doing good, especially the ICC students. It's been so long since we have last met. I hope all of you guys are, preparing well for your boards and stuff, and staying healthy, and more importantly, staying warm because it's very cold out there, and it's been raining for like I don't know how many days now in Bangalore. So I hope it's better in your place at least. So welcome to the session, people. Welcome to the one-shot series. We are back again with a bang, and today we're going to be doing the refraction of light through lenses, part number one. That is session number one of this one-shot series. Once again, I hope that you guys would take down the notes. I will be uploading the PDF of this session, so do not worry about that. We're going to keep it very light, very sweet. We'll try to get through the basics of lenses in today's session. That is going to be our aim for today. We'll try to get through the basic stuff, some of the common terminologies, and few things that you must be aware of when you deal with lenses. That's exactly what we're going to do in today's session. So to sit back, relax, enjoy the session, and more importantly, hit that like button, subscribe to the channel, right? So yeah, guys, these are the topics that we're going to be doing in the days ahead. We'll start with a lens and its component. We'll understand about refraction through a lens and its focus. We'll talk about action of lens as a set of prism. All of this in today's session. Principal rays of ray diagram and ray diagrams of both concave as well as convex lenses. We'll also understand about sign convention, lens formula, numericals, and power of a lens. Now we're going to keep it into two. We're going to divide the session into two. We'll understand the basic stuff today, and the rest of the session, basically the things that will follow later, we would be covering the rest of the topics as well, right? So let's get started. Let's start with a very simple topic, guys. Let's talk about lenses and its components, right? Let's talk about what exactly is a lens first. See, guys, in our day-to-day life, right? For example, I'm using my spectacles in order to see sharper. Now, the spectacles that I'm using has lenses. You might have guessed it right. The camera that is recording the video as we speak has lenses on it. The projectors that you go and enjoy the movies in have lenses in them. So lenses are all around you. So understanding how and what type of lens is used in a certain application, in a certain object, or certain object is the better word, right? That is very important because you must be able to at least figure out what type of lens is being used in a certain thing. So let's try to understand what is the basics of a lens and what are the different parts of a lens. So to talk about a lens, how would you define a lens? A lens is defined as a transparent medium. Transparent means which allows all the light to pass through them. It's a transparent medium which has at least one curved surface. That's all. If you have a transparent medium which has at least one curved surface, that can be called as a lens. Now, one of the two basic type of lens that we have is a concave lens and that of a convex lens. Now, if you look at the difference, if you look at the structure, you can figure out what is the difference between them. A concave lens is one which is thin in the middle but thick at the edges. Now, this is also called as a diverging lens. I'll tell you why it's called as a diverging lens as we move ahead. But yeah, on the other hand, when you talk about a convex lens is one which is thick in the middle, whereas it's thin on the edges. Now, the thing about this is that it's also called as a converging lens. Now, why is it called as a converging lens and why is the other called as a diverging lens? I'll talk about that as we go ahead. Now, what you need to understand is this, guys. Although these are the two type of lenses that we are using and we study a lot about these two lenses, these are not the only type of lenses that we have. Actually, if you think very carefully, guys, if you look into the market, like if you look at the objects that you see around you, you can see different types of lenses. You have something called as a plano concave lens, plano convex lens. We have concavo convex lens, convexo concave lens. So all of these are the different types of lenses. Again, the way that they refract the light would be different. But here's the thing. Don't worry, because we are going to be dealing with only biconvex and biconcave lens, which means that both the surfaces are convex or both the surfaces are concave in nature. So that is the only thing that you need to remember. Now, again, you'll be learning about these types of different lenses in the future. You'll be definitely going through all of these. But for now, you don't have to worry about it at all. So this is when you talk about concave lens, you have biconcave lens, you have plano concave lens where one side is plane and the other side is concave in nature. And finally, we also have convexo concave lens. It's a combination of both convex and concave lens. Again, more about this you'll be studying in the days ahead. Now that you've understood what are the different types of lenses, guys, you need to also understand what are the different parts of a lens, because it's important, because you're going to be doing a lot of ray diagrams in this particular chapter, which is very, very, very important. In fact, guys, the ray diagrams can also help you solve your numericals as well. So that's is in general, I don't think I have to stress a lot on it, but it's very, very, very important. So keeping that in mind, let's talk about different parts of the lens. What are the different components of a lens? What are the different parts of a lens? The first one that you need to deal with is called as the center of curvature. Now, what exactly is that? See, guys, if you remember, when we talked about mirrors, I told you that a mirror, a concave mirror or a convex mirror, is basically a part of a single glass sphere. So from a glass sphere, if you cut a small portion, that gives you a concave or convex mirror, depending on which side you decide to silver. Now, the thing about a lens is that a lens has not one, but two spheres. A lens is made from two separate spheres. And more importantly, the spheres, just like a circle. Now, if you think about a circle, guys, a circle has a center, right? A circle has a center. In the same way, a sphere would also have a center. It's not a sphere is nothing but a three-dimensional circle, isn't it? So the center of the sphere is called as center of curvature. Simple as that. The center of the sphere from which you got your lens, or from which the lens was the lens was a part of, or from which the lens was derived from, that is called as the center of curvature. Now, just like a circle, you also have something in a circle. You have something called as radius, right? Radius is nothing but the distance from the center to any point from to that circle. Now, again, a sphere is a three-dimensional circle, and hence it also has a radius, but rather it has two separate radius of curvature. Now, although people, the ones that we are dealing with at this point of time, both the spheres are actually of the same diameter or of the same radius. Now, in your higher grades, you'll also be dealing with different, radius. One might be more, the other might be less, but all of those again in your higher grades, so you don't have to worry about it. You already have a lot of tension, ICC students, I understand. So chill out and think about only things that you have in the syllabus right now. Don't worry too much about all of these. Right, coming back to the topic. So radius of curvature is nothing but the radius of the sphere. As simple as that. The distance from the center to any to the circumference of the circle, the distance is called as the radius. And here you have two radius of curvatures because you have two separate spheres. Moving on, people, we also have something called as the optical center. Now, the thing about optical center is it's very close to pole. Remember the pole in the case of a mirror? A pole is what? It's nothing but the midpoint of the mirror. Optical center is the midpoint of the lens. That's all. Simple. Optical center is what? The midpoint of the lens. Pole is the midpoint of the mirror. Optical center is the midpoint of the lens. That's all. Kel khatam, dukaan band. Then we have aperture. Aperture is nothing but, guys, the entire refracting surface. The entire refracting surface. For example, guys, if I talk about my phone right here, no, you see, these lenses, right? You have these three separate lenses that is there. Now, the thing about these lenses is that they allow the light to pass through them, right? So if I have a lens, let's say this is a convex lens that I have on this particular phone, wherever light can fall and refract or undergo refraction, that entire refracting surface, wherever light can fall and refract, that is called as the aperture. Just like a mirror, in mirror also we told you that the entire refracting surface is called as the aperture. In the exact same manner, the entire refracting surface of a lens is called as the aperture. And finally, principal axis is nothing but a straight line passing through both the center of curvature and the optical center. That's it. So these are all the terminologies that you must be aware of. If you want, pause the video, take a screenshot of this. I have already explained everything. If you guys want, you can go through this one more time, right? Moving on, guys. Right. Apart from this, you must also know what is the type of refraction that happens in these two types of lenses. For example, in a concave lens, how does the refraction happen? And in a concave or convex lens, how does the refraction happen? Now, again, this is something that we've already dealt with Again, if you want to go through it one more time, it's absolutely fine. The picture is right there. Again, like I told you, I'll be uploading the notes as well. So whenever you're free, whenever you want to refer a little bit more, always download the PDF and refer to it whenever you want. Coming back to the topic, as I was telling you guys, the way that the light refracts in a concave lens and that of a convex lens is completely different. For example, in a convex lens, for that matter, imagine that there are two rays of light which are parallel to the principal axis, and it comes and falls on this lens. Now remember, this ray of light is initially entering from air to glass. There's a change in medium, which means that there is going to be a change in speed, which means that it'll undergo refraction. As the light is leaving the lens and it's entering into air, again there's a change in medium because it's now leaving glass and entering into air. So once again, it'll undergo refraction. So in the case of a convex lens, guys, the way that the refraction happens is that if I have several rays of light, after refraction, as long as they're all parallel to the principal axis or parallel to each other, after refraction, they will all end up meeting at a certain point, a certain fixed point on the principal axis. Now, again, it's not just true for these two rays of light. If I take n number of rays of light, it really doesn't matter. As long as they're all parallel to each other, as long as they're parallel to the principal axis, after refraction, they are all going to meet at a single point on the principal axis. And that point where these rays of light are meeting after refraction, that is known as the focus. It's nothing but the point or the point of convergence on the principal axis that is known as the focus. Now here, in the case of a convex lens, what you have is a real focus. Why is it called as a real focus, you might ask? It's because, guys, the rays of light are actually meeting. They are actually intersecting at that particular junction. That's why it's called as a real focus. But when you talk about a concave lens, that's a lot more different story. Because here, guys, again, two set of refraction. First set of refraction happens over here. The second set of refraction happens as it's leaving. But here, the rays of light are going away from each other. They're never ever going to meet. They are like your, like your childhood dushman, like your childhood enemy who you never want to meet again. You have, every one of us have that one friend in LKG that you hate the most. I don't know. I had one such friend. Probably you might have one as well. But yeah, we always go our separate ways, right? So this is exactly what happens to these rays of light as well. They are all going away from each other. But for a person who is standing on the other side, when these rays of light comes and falls into his eyes, his or her eyes, what happens is, guys, your eyes, when they are trying to trace back the source of the light, it appears, let me stress on that word, it appears to converge at a junction. It is appearing to originate from that point. But is it actually coming from that point? No, it isn't. But it appears, it gives you that illusion that the light is originating from that point. And that point where these rays of light are appearing to meet, again, stress on that word, appearing to meet, that is called as the focus. Now here, what you have is a virtual focus because it's not real. No, it's not actually meeting, but they're only appearing to meet. And hence, it's called as a virtual focus. So on one hand, you have a convex lens, which is a converging lens, which has a real focus. On the other hand, you have a concave lens, which is a diverging lens. And more importantly, it has a virtual focus. Now, guys, going into a little bit more technical stuff. Now, remember in your lower grades, probably studied about how light refracts when it enters into a prism and how light refracts when it enters into a rectangular glass slab and stuff. Probably studied this in this particular year itself. Now, one of the things you need to remember is, guys, when light is entering into a glass prism, it always bends towards the base of the prism, right? So in a convex lens, you can say that a convex lens is made from three separate prisms, you can say. One is a rectangular glass prism. The other two are triangular glass prisms. So two triangular prisms, one at the top, one at the bottom, and then in the middle, you have a rectangular glass slab. When you talk about a concave lens, on the other hand, you have two trapezoidal prisms, and then one rectangular prism. And the way that light refracts, imagine that there is three set of light or three rays of light coming and falling onto these three surfaces. The way that they refract is very much similar to what you just saw right now. Let me show you that. Let me just show you that. Look at that, guys. After refraction, these rays of light will again end up meeting at the focus itself. That is for a convex lens. On the other hand, for a concave lens, again, after refraction, again, these are two trapezoidal prism. So after refraction, they're going to bend towards the base. And you see that after refraction, they will appear to meet at a point, which becomes the focus. So you can assume that a prism, you can assume that a lens, be it concave or convex, is made from spheres, from prisms as well. All right, not spheres, but yeah, from prisms as well. Spheres you have already studied, but it can also be said or depicted in this manner. Now, guys, we're going to get into something even more serious now. Standard incident rays. Now, what exactly are standard incident rays? See, people, when you talk about image formation, right, you need two rays of light. That's all. It doesn't matter which, if it's a reflection or refraction, whether it's a spherical mirror or a spherical lens, it really doesn't matter. You just need two rays of light in order to form an image. And if you imagine, let's say an object, let's say the bulb, or if I talk about the light that is coming from a torch, there are millions of rays coming. So you can basically form image from any of the two rays. Now that's easy, right? But is it that easy? Is it really that easy? Because if you just think about it for a second, if I have, let's say, a convex lens, I have to imagine there's a ray of light coming and falling. I have to first figure out what is the normal to this surface. So normal would look something like this towards the center of curvature of on this side. I can call this a C2, which is the center of curvature on the other side. So basically, guys, you would have to find out the normal, then find out the angle of incidence, then find out the angle of refraction, which is definitely not something that I'm looking forward for. I'm pretty sure none of you guys want to do it as well. Would you want to, sit in your exam hall, sit with a protractor and a compass and a scale and sit and do all of this for 15-20 minutes? Let me know in the comment section, right? Do you really want to do that? I for sure would have never, ever even, thought about it for a second, because I would have never given it a second thought. I would have skipped this completely because 10th standard, you want easy work. I understand. We all done it. But when you talk about, making your life a little more easier, we have something called as a standard incident rays. Now, what is a standard incident ray? Rather than doing all this work of finding out the angle of incidence, angle of refraction, finding out the normal and all that, what they did was that they took three incident rays, three standard incident rays. Now, these three standard incident rays are more than enough to figure out any type of ray diagram. Wherever the object is kept, you can figure out what is the exact position. We can find out what is the type of image, everything using just these three standard incident ray. No needs of protractor, no need of a compass, no need of anything, just a scale, and you're good to go. So yes, how exactly does it work, and what are the three standard incident rays? The first standard incident ray is one which is parallel to the principal axis. Imagine there's a ray of light which is parallel to the principal axis and it's falling on a convex lens. What should happen to that? Now again, if you were to follow the traditional method, finding out the angle of incidence, finding out the angle of refraction, that's a lot of work. Instead, you can directly say that if a ray of light is parallel to the principal axis, after refraction, it is definitely going to pass through the focus. Simple. Directly, without doing any sort of calculation, you can directly say that that ray of light which is parallel to principal axis after refraction is going to pass through the focus. Simple. Kel khatam, dukhan band. Second is, if a ray of light is passing through the center of curvature, it is going to pass through undeviated. There'll be no deviation whatsoever. It'll pass through unrefracted, or there'll be no refraction. It'll just pass through straight. Second standard incident ray. Third standard incident ray is if a ray of light is passing through the focus after refraction, this ray of light will become parallel to the principal axis. That's all. And this is true even for concave lens also. But the only difference is that it's a diverging lens, right? So after refraction, this ray of light will appear to pass through the focus. That is the only thing you need to add. The word appear to pass through the focus. If a ray of light is passing through the center of curvature, it'll pass through undeviated. And if a ray of light is passing or is parallel to the principal axis, again, the arrow mark over here and here also it's given as wrong. It will be like this. After that, it'll become parallel to the principal axis. And again, if it is passing through the focus after refraction, it'll become parallel to the principal axis. That's it. Voila. Those are the three standard incident rays. And just by using these three standard incident rays, my friends, you can do any given ray diagram for any given object position. It doesn't really matter. You can figure out any given object position, both for concave as well as convex lenses. Right. Now that is out of the picture, let's now talk about the ray diagrams. Yeah, the smirk. You can feel that, no? Because ray diagrams is where a lot of you guys struggle. But trust me, guys, there's nothing more easier than this. To be honest with you guys, there is nothing more easier than this. If you know the standard incident rays, this is where you can easily score marks. No calculation required. If you can use a scale and approximately mark the position, you're good to go. No need to worry about anything. Your marks is yours. No handwriting. There's no deduction for handwriting, nothing. You just need to draw it out and you're good to go. And this is coming from one of the world's worst artists. All right. That is how easy it is. But anyways, let me just don't over exaggerate it. Let me deliver. First thing, guys, if there is an object that is kept at infinity, remember this. If an object is at infinity, you are only taking those rays of light which are parallel to the principal axis. Please remember this, all right? If an object is at infinity, for example, imagine sun or a distant tree, whatever it is. If it is at infinity, then you're only taking those rays of light which are parallel to the principal axis. If a ray of light is parallel to the principal axis, according to the first standard incident ray, it has to pass through the focus. Simple funda. So because of that, guys, if an object is at infinity, the image will be formed at f2. f1 is on the left hand side, f2 would be on the other side, because you have two spheres, right? Two center of curvature, two focal length, and two radius of curvature as well. So here you have the image formation happening exactly at f2. If you look at the type of the image is going to be diminished. In fact, it's going to be point-sized image. It's going to be a point-sized image. It is going to be a real image, and it is going to be inverted in nature. Now, please remember this, guys. All real images are inverted in nature. All real images are always inverted in nature. And all virtual images are always going to be erect in nature. All right, all virtual images are erect in nature, all real images are inverted in nature. So because of that, the image you're going to get is DRI, that is point sized or diminished, and real and inverted. Now I'm going to bring the object a little bit more closer. Now the object is just beyond 2f1. If the object is beyond 2f1, again, I'm going to take two standard incident rays, one parallel to principal axis, the other passing through the center of curvature. And where are those two rays of light meeting? They will meet between f2 and 2f2. That's all. And if you look at the size of the image, again, it is going to be diminished, real, and inverted. Here it's going to be point size, so you can say that it's point size PRI because it's point sized, but it's still diminished, but it's going to be a point sized image. Next is when you keep the object at 2f1. If the object is at 2f1, this is the only condition where the image is going to be of the same size. It is going to be real and inverted. Again, two standard incident rays, one parallel to principal axis, the other passing through the center of curvature. And these two rays of light are meeting exactly at 2f2. And it's going to be of the same size. It is going to be real and it's going to be inverted. Moving on to the next one, bringing it closer even. Now the object is placed between 2f1 and f1 as the image formed beyond 2f2. And if you look at the size of the image, this is the first condition out of all these that we have seen. You're going to get an enlarged image, but real and inverted. ED. Enlarged, real, and inverted. Moving on, if you keep the object exactly at f1, exactly at the focal point, then the image is going to be formed at infinity. Two standard incident rays, one parallel to principal axis, the other passing through the center of curvature, and these two rays of light will be meeting at infinity. All right, it's going to be highly enlarged, highly enlarged. It's going to be real and inverted. And finally, guys, when the object is placed between F1 and the optical center, this is that case where you're going to get a different scenario. This is that one case where you are going to get a virtual image, because if we look at all the other images, it's always been real. But this is that one condition where you're going to get a virtual image which is erect and which is going to be enlarged in nature. In other words, simple. So you look at this: two standard incendiaries, one passing through the center of curvature, passing through the optical center, and the second one is parallel to the principal axis, and these both are diverging away from each other. So when you extend these rays of light backwards, you see that they will meet at a point on the same side as that of the object. You have to extend them backwards. You see this? They're both diverging away, right? So when you extend them backwards, they are both meeting at the same point, but on the same side as that of the object. That is why you're getting a virtual image, erect image. Virtual images are always erect. So virtual and erect, that though is already done. With that, it's also going to be enlarged in nature. So these are all the ray diagrams, guys. Please go through them. Now to talk about concave lens. The concave lens, though, don't even talk about it. It is as easy as it gets. No matter where you keep the object, it doesn't matter. The image is always going to be virtual, always going to be erect, and always going to be diminished. In other words, Vedantu's virtual, erect, and diminished every time. Doesn't matter where you keep the object. If the object is at infinity, image is going to be formed at F1. Diminished, erect, virtual. Anywhere between infinity and the optical center, doesn't matter where you keep it, the image is going to be formed between F1 and O, between F1 and O, and it's going to be diminished, erect, and virtual. Simple as that. How easy is that, people? So for all those who thought that this was difficult, it's not. You just need to practice a little and you're good to go. Right, guys, now I have a lot of questions in store for you guys just to check your knowledge. But before we get into the questions, guys, I want to ask you this question. Do you want to get better at what you're doing right now? If the answer is yes, guys, then I have a solution for you guys. When I say better, I am talking about in every sense of the word. When I say better, I am talking about you understanding every single concept that you're studying, you getting more questions to practice more and more, you're getting more of everything so that you can improve completely as a student in that particular topic. So here is an opportunity for you guys, given up by Vedantu, to educate and to spread the word with you people to ensure that you guys are all in the right track. So let me just quickly tell you how and why should you choose Vedantu. So firstly, guys, what you have to do is go to the link that I'll show you in a minute. But before that, let me tell you why Vedantu, right? First of all, guys, all of the sessions are recorded, right? So you can refer to the sessions whenever you want. Wherever you want, you can always go through the recordings. Now, in YouTube, the thing is that you can't actually do quizzes, right? You have to go to the Mentimeter and then do the quizzes. But our own platform has quizzes already inbuilt inside of it, which means that not only will you have fun learning, but you also be testing yourself every other 5 to 10 minutes, because we'll have quizzes throughout the entire sessions to check how much is your progress, and this will help you for your term 1 preparations, and more importantly, it'll keep you motivated. We have leaderboards, we'll have fastest fingers list, we have drums, we have stars, again all of this to encourage you guys to do better, because in Mentimeter the problem is only the first 10 names can be seen. Out of 500 people, only the 10 people are appreciated. But here we are making sure that every one of you guys are appreciated, because you guys do deserve appreciation for your efforts. With that, people, you can get to talk to the teacher as well. So you can see this over here. One of the students called as Srikanth was talking to me in that particular session. In the sessions in YouTube, that is not possible, right? I am the only one who's talking to you guys, and the only way that you can talk to me is through the comments. And yes, we do check that. But it's not always optimal, right? So if you have a doubt, you can always get unmuted in the session and get all of your doubts cleared right there and then. With that, you also have something called as a doubts panel. I don't know if you can see this. So if you go to this doubt panel, right, you'll have one set of class teachers waiting to solve your doubts. So you have not only one teacher, but an army to clear your doubts to make sure that you're going in the right path. In fact, guys, this is one of the statistics of that particular session. There were 136 doubts that were asked in that session. And out of that 136 doubts, all of that 136 doubts were cleared, and 7 of the doubts were actually broadcasted in that session. Broadcasting in the sense, if I feel like there is a doubt that can help the entire class, I can even broadcast that, or a certain message that I feel like the entire student community must know. We can even broadcast those messages as well. And apart from that, we'll have the telegrams groups. We'll have lots and lots of fun during the session. We'll make sure that all of your concepts are understood, and more importantly, we'll make sure that you're getting every single support you need to go in the right track. And to top it all off, guys, you can always download the notes as well. Whichever session you're in, you can always download the notes. Everything that is written, my handwriting is very clean, as you can see that. So you download all the notes, and I generally start off every session with a riddle. So like I told you, you'll have a lot of fun, and more importantly, we'll also make sure that you're learning and understanding every single concept you have. So how do you enroll, right? That's the next question. So people, what you have to do is very simple. Go to the description of this video that you are seeing right now and click on ICSE 2021-2022, because you're going to be giving your exams in 2020, right? Now here you can see for yourself, people, the entire grade 10 ICSE school tuition, the entire class, the entire revision course, entire course, that is your micro courses, everything would be given to you guys within this one particular class itself. So you have 3 types of programs that is offered by Vedantu. Again, this is there in order to give you a choice, and more importantly, the features might be a little different in all the 3. So if you go for Vedantu Lite, right, you get all the basic features that you need. Every single basic feature, revision classes, you'll get assignments, you'll get everything that you need. But the only thing is that you'll not have the doubts app. Now, let's say that you have a doubt outside the session and you want to get that cleared. With Classic, you can also get the doubts app, which means that you can download the app for free and get your doubts solved. How many ever doubts you have, clean, bold, right there and then. Then you have Vedantu Plus, where you also get, with the Doubts app, you'll also be getting someone called as an academic mentor or the personal teacher who will make sure that he's with you from day one until the last day to ensure that you're getting every single support that you need. You'll be getting one-to-one sessions. You'll be getting every single thing. Even this minute details, they'll be taking care of you to ensure that you're going in the right track. Now again, the price is different. The price, as you can see, for Lite is around 18,000 rupees. Now, I know that it's a lot of money, especially for a middle class family, because I know that even I was in a middle class family. I still am, by the way. So yes, in a middle class family, 18,000 rupees is a lot of money. So here we have an option for EMI, guys. You have to just pay around 1,500 rupees per month. Now, 1,500 rupees per month is like one pizza, or maybe 2 pizzas. That's all. And a Domino's, though, it's hardly 1-2 pizzas. That's all. 1,500 rupees for your education, not for 1 month, 2 months, for the entire course, starting from today, from the day that you enroll until your term 2 examination, until your exams are done. That is until April, May, whenever your exams are done. Until then, for just 1,500 rupees per month. Now, let's say that you wanna, test the water first. Like when you're going out a swimming pool, you don't just jump into it, right? You always check the temperature. Let's say that you want to do it like that way. You also have the trial for 15 days. Now, hear me out, guys. Trial for 15 days is 170 rupees. But if you use my link right now, that 15-day trial will be increased to 30 days. That means that for the price of 15 days trial, you'll be getting a 30-day trial. You heard that right. 30-day trial for just 1,170 rupees. And in that 30 days, you'll get everything that you need. Assignments, test, classes, doubt solving, everything for 1,170 rupees. All of the subjects, everything included for just 1,170. It cannot get any better than that. 30 days for just that amount of money. Nowhere will you get that kind of offer, guys. Nowhere. Trust me on that. All right. And yes, you'll be getting the best of the best teachers. You'll be getting the best of the best, whatever we can offer to ensure that you're on the right track. The choice is yours. You have to make that call. But let me tell you one thing, guys. Don't have regrets in life. Don't have regrets in life. That's the worst kind of feeling that you can ever have, right? So do not have regrets. So try your best to talk to your parents and see where you can, to ask them and tell them what is the importance and what you're getting out of this entire course, right? Don't think about that 18,000 rupees, but think about how much value for money you're getting out of it. That's what is more important, because trust me, guys, if you go and buy a PlayStation that's like 25,000 rupees, gone right there. It's not going to get you anything, right? This is for your own life. So think about it. Your life, your choice, right? So people, let's get back to the questions now. This is the chance for you guys to test yourself, to test how well you have understood the concepts. So I'm going to ask you a series of questions. What I want you to do is very simple. Jot down the answers, whichever you think is the right answer. More importantly, I want you guys to put down the answers in the comment section. Let me see how many of you guys get or have gotten all the questions right. So let me know in the comment section. I'll be waiting for that. So here is your first question, guys. Take a look at this. Read the question carefully. If you need more time than what I'm offering, please pause the video and get the answer. So here's the first one. A ray of light incidents on the optical center of a spherical lens. After refraction passes through what? So if there's a ray of light passing through the optical center, after refraction passes through what? Options are principal focus, radius of curvature, twice the focal length, or the optical center itself. I mean, jujube level question. Jujube. This can't be called as an easy level question. This is jujube questions. Please remember that word. You're going to need it in life. Jujube. All right. The answer is going to be in 3, 2, 1. Optical center. Because a ray of light passing through the optical center will pass through undeviated without any deviation whatsoever. So it's going to pass through the optical center itself. Easy question. Second one. Let's go. When light travels from air into glass of a convex lens, it bends dash the normal, away from the normal, towards the normal. It does not bend at all, or along with the normal. Oh, wow. What an amazing option. Please don't choose option number D. All right. Do not insult yourself by doing that. But yes, go ahead, people. So you have 3 options to select from. Think carefully and then answer, because this is one of the most important questions. Some of the most fundamental things that a lot of students go wrong in. So think very carefully and answer. I will give you the answer in 5 seconds. Again, if you need more time, pause the video, put on the answers. Let me know in the comment section if you got it right or not. Be honest, all right? It's important. All right. In 3, 2, 1, it is going to bend towards the normal. Let me tell you why, guys. Because when light is entering from air to glass, light is entering from a rare medium into a dense medium. And when light is entering from a rare to dense medium, it's always going to bend towards the normal. On the other hand, if light was entering from glass to air, it would have bent away from the normal. Simple funda, right? Third question. Is the optical center always at the center of a lens? Options are only if both the curved surfaces are asymmetrical. Yes, never. Only if both the surfaces are symmetrical. Now, I know that a lot of you guys would have gone with yes. First of all, it's highlighted on top of that. One of the most very obvious questions to answer. But let me tell you this, guys. It's not. It's not. Is the optical center always at the center of the lens? No, it's not. Let me tell you why. See, guys, in a bifocal lens, biconcave or biconvex lens, it makes sense. It is going to be at the center. It's going to be at the geometric center of that lens. But what about a planar convex lens? Or a planar concave lens? Or a concavo convex lens? Or a convex or concave lens? Would that still be in the center? No, it will not. As long as it is symmetrical, then it will be in the center. Symmetrical in the sense, exactly if you divide it into half, the left side should be equal to the right hand side. Simple. If it is symmetrical, then it will be at the center. If it is asymmetrical, then it will be not. Because, for example, if you talk about planar concave or convex or concave and all, they are not symmetrical in nature, right? So for them, the optical center would not be exactly in the middle, right? Next question. Here is the question that I've been waiting for. This, though, I want to know How many of you guys will get it right? I want to know. Fourth question. Do not copy, do not, go and Google it, but here's the question. An object is situated at a distance of f by 2 from a convex lens of focal length f. What will be the distance of the image? Options are minus f by 2, plus f by 3, minus f, or plus f by 4. All right. Now here's the thing, guys. First of all, write down what is given to you. All right. So object distance u is given as f by 2. Focal length is given as f. Now people, it's a convex lens. Object distance will always be minus. So it will be minus f by 2. Now here you have to use lens formula. Now unfortunately, I've not talked about lens formula. I've not told you anything about lens formula, but I'm guessing that you already know it. Even if you do not, we will be coming up with another video for numericals alone. So don't worry, subscribe to the channel. All right. But yes, I will be coming up with another video for that. Don't worry about it. But for a small sneak peek, shall we say, right? A small sneak peek, like a trailer, this is. So how do you solve this question? So guys, the lens formula is 1 by v minus 1 by u is equal to 1 by f. There's the formula. So 1 by v minus of minus f by 2, right? So it'll be 2 by f, which will be plus 2 by f, because it's, again, it is 1 by u, right? So 1 minus of 1 by u. So minus of 1 by f by 2 can be written as minus into minus becomes plus, so it will be 2 by f, which is equal to 1 by f. So what is 1 by v is equal to 1 by f minus 2 by f, which is nothing but what? Minus 1 by f. So what is v equal to then? Minus f. So the answer is going to be option number C. Again, I have not talked about lens formula yet. I've not done it yet. But in the next session, I will be talking about it. So don't worry, subscribe to the channel, hit that like button. All right. Fifth question, guys. Here it is. Oh my God. This is from the ray diagrams. Direct ray diagram wala question. The convex lens produces a real image of the same size as that of an object when the object is placed at twice the focal length, at infinity, at the principal focus of the lens, between the optical center of the lens and the principal focus. Think, a convex lens produces real image of the same size of the object. When do you get an object which is of the same size? It's very, 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 very straightforward, very simple. I hope you have gotten the right answer already. I'm going to give you the answer in 5, 4, 3, 2, 1, twice the focal length. When the object is placed at 2f1, the image is going to be placed at or formed at 2f2, and it's going to be of the same size, real and inverted. And that, my friends, is the end of today's session. But that does not mean that we have ended the whole one-shot series. No, we still have a lot more to come. There's a lot of things that is in the pipeline for all of you ICSE students out there, and this is something even CBSE students can find super duper helpful in. So I'll see you guys in the next one, and take care of yourselves. All the best for your exams, and more importantly, like that video, subscribe to the channel, and also may God bless you. All right. Ciao, adios, konnichiwa. Take care. See you soon. Bye-bye.